Okay, folks, welcome back to another one of these exam videos, and we're still on exam 1 from 2015 fall semester, and now we're on question number 12. It says, how many resonance, I think we're on question number 21, I'm sorry. Which compound below has has atoms that have an incomplete octet? And we have 5 choices over here, which I believe this question requires the ability of drawing Lewis structures. But actually, you can, if you don't know how to do that, you can still reason through it. But I prefer the way of drawing Lewis structures, which is also a very essential skill in your further chemistry study in Chemistry 1 class. So, starting at the end of the choices, let's start with E. It's E. So it's iodine with 5 chlorine. Oh, no, wait, what? And let's put iodine in the middle since it's the most electropositive stuff, and we just like put down chlorines around it, and we connect them together. And how many? Let's calculate how many electrons does it have. It has 7. Iodine has 7, with chlorines has 5 of each. So it's the iodine pentachloride has 42 valence electrons in total. And we used up 10, so there's 32 left. And let's put like those electrons around the chlorines and see if that works out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. And there's one extra. I think I did something wrong with the counting. There should be an even number. It's 6 for each, and we have 5, so it's 30 instead of. And we just put like the extra 2 over here, and we used all the electrons, which is the correct Lewis structure of this atom. So it does not only have an complete octet. It has 1, 2. The iodine in the middle has 1, 2, 3, 4, 5, 6 pairs of electrons around him. So this is actually an exceed octet. I don't really know how to spell exceed. CED, something like that. Octet. Okay, so the choices number E eliminated. And let's take a look at D. It's carbon dioxide. So as the way we draw it over here, as the way we draw like the E over there, the E over here, we do it was the same as the D choices, which is carbon. Let's put carbon in the middle and put oxygens around it and connect them together. And I guess we should start with like in a more traditional fancy ways that we start with calculating the valence electron, which carbon has 4, and and oxygens has 6 valence electron each. So the total number should be 16 valence electrons. And let's put carbon in the middle with oxygens on the sides. So these are 4 electrons, so we still have 12 left. I have no idea what's wrong with this pen. I got some new equipment, so it should work okay. And let's put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then for this particular question, we have to make sure that the carbon must complete its octet, since it's it cannot just no, we can just. I feel like it's make more sense if we just calculate like the formal charge of each species. So for oxygen over here, it's 6 minus 7, which gives us -1. So it's -1 for oxygen, -1 for oxygen. And for carbon, it's 4 minus 2, which is a +2 for carbon. And so we can probably like shuffle around these electrons a little bit to make it look a little better. That's just clearly process out the things that we don't actually need. I don't need this either. And let's move this pairs of electron over here. So now the formal charge reduced to 0. And belongs to, here we go. So 0, and this reduced to +1. And we just move it, we just do the same thing again until like everything seems to work out. And now that's reduced to 0. Let me just fix it. Okay, cool. So for the answer number E over here, I would say that like if you calculate the formal charge, you'll find out that all the chlorines and except the iodine is probably in a higher charge. It's no, all of them are 0 actually. So it's a rather perfect Lewis structure, and this one is too. Like all the species at this moment has a formal charge of 0. So it's quite a good, it's quite good of a Lewis structure we draw. So, and according to this graph over here, we can see that uh, every particular. Let me just get out something that I can circle it with. Not so sure what I can do with this, but whatever. I lost my. What the heck? Never mind. I just redraw it real quick. Like yeah. Okay. So for this particular one over here, it looks obviously that everybody has a like a like this one has a complete octet with 1, 2, 3, 4, 5, 6 1, 2, 3, 4, 5, 6 1, 2, 3, 4, 5, 6, 7, 8 electrons. And this one has 1, 2, 3, 4, 5, 6 1, 2, 3, 4, 5, 6, 7, 8 electrons. And this one has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So it all has complete octet. Go back and look at choices number C, I mean. And it's it's carbon monoxide. So as usual, we just put on like 4 plus 6 equals 10 valence electrons, and we just connect those two things together, and we get a minus 2 minus 2 electrons. We get 8 electrons left, and we still have 8 electrons left. Let's put the electrons around the oxygen first, which requires 6 valence electrons, so it gets down to 2 electrons. And we just put the extra 2 over here. And with the formal charge issues, this one is obviously +1, and this one is obviously -1. And we have to shuffle this around a bit to make it a better Lewis structure. So let's shuffle this pairs of electrons and make it become a bond. So now, actually now all the formal charge is 0, but because carbon must complete its octet orbit, so we have to move another pairs of electrons to the middle, towards the middle, in order for the carbon to complete its octet. So that's 1, 2, 3, 4, 5, 6, 7. So that's let me just count it out. 1, 2, 3, 4, 5, 6, 7, 8 electrons. And for this one is 1, 2, 3, 4, 5, 6, 7, 8 electrons as well. So this one also has a complete octet for its answer. So C is not also not the answer. Okay, save it. And for choice is B. It's chlorine. So it's 7 plus 7 equals 14 minus 2 equals 6. It equals 12. I'm sorry. What I mean is 12 electrons. And we just put down those electrons around the chlorines. And that fits perfectly and give us a octet for both species. And it also gives the formal charge of 0 on both atom in the molecule. So B is not the answer too. And for the last one, actually, from my own experiences, boron usually reacts more like a metal instead of a non-metal, so it should be the answer. And let's take a look. So let's put so boron has 3, and each chlorine has 7, and there's 3 of them, so it's 3 times 7 plus 3, it's 24 electrons. And let's put down boron in the middle. This is one of them. Yes, it is boron. And connect F, F, and F. So minus 1, 2, 3, 4, 5, 6. We still have 18 electrons left. Let's just put down those things around the fluorines, and it works out perfectly. So due to the fact that usually when you see boron, it's always not. They don't usually have a complete octet because they only have 3 electrons. It's hard for them to get a covalent, get at least 5 covalent electrons to make themselves a complete octet. So usually they just give up their electrons to form somewhat kind of like an ionic bond, and so they usually have incomplete octet, which gives us the A is the correct answer. And actually, this is one of those hard problems that requires some advanced skills in chemistry, so you don't really need to pay too much attention to. Well, not pay too much attention, but I would say it's hard to prepare for those problems. So I encourage you to go to the instructor office hours and do more questions in order to prepare for these kind of issues. All right, we'll end here. Can I get this up, please?